My last video for the problems in section 1.6 got interrupted, so I have 2 more problems to do, and I'm just going to post them, 3 more problems to do. I'm just going to post them in this separate video for 1.6. So we were getting ready to start problem number 75, which has this graph a transformation of the square root function. If I think about the transformations in order here, I'm going to start with a shift left 2. And then this 1/2 out front, that's a vertical compression by a factor of 2. All right, well, let's start by graphing that parent function, y equals root x. All right, just take a bunch of square roots. 1, 2, 3, 4. Square root of 4 is 2, and we know we have this pretty graph. And now I just need to perform these transformations. Let's go to the left 2 units. Compressing a point at y equals 0 by 1/2 doesn't do anything. Left 2, that's a y value of 1 times 1/2 is 1/2, and then left 2, 1, 2, compressed by a factor of 2, so y is 2 times 1/2 is 1. And there's that nice happy answer to number 75. That's that function g of x. 1/2 root x plus 2. Well, 76 has us do another transformation of the square root function. This time it has this graph a function that they call g of x equal to 2 root x plus 1. I have another left shift. And this time, a vertical stretch by a factor of 2. So I'm going to use the same graph, transforming the blue y equals root x. Left 1, stretched by a factor of 2. Well, 0 times 2 is still 0. Left 1, 1 times 2 is 2. Left 1, 2 times 2 is 4, so 3, 4. Shifted left 1 and stretched vertically by a factor of 2. So there's our solutions to 75 and 76, and that just leaves us problem number 94, which has us put 3 transformations together in an absolute value graph. Here we're asked to graph g of x equals minus 2, absolute value of x plus 3 plus 2. With that minus out front, actually 4 transformations. I was thinking of a minus 2 as doing 2 things at once, but when I write my list, I will write 4 separate things. We start on the inside. We go left 3. Then we're going to stretch vertically by a factor of 2. In class, usually someone asks me, hey, what are you going to do with that minus? Well, that's the third thing. That's where we reflect over the x-axis. And then finally at the end, I see that shift up 2 units. I'm going to start with an absolute value graph without any changes at all. We know that's that nice happy V shape. All right, and then I'm going to do some of the transformations together and then draw one final answer. So I'm going to start by doing these 2 together. Right, I'm going to go left 3, and I'm going to stretch vertically by a factor of 2. Left 3, 1, 2, 3. The stretch doesn't affect this point on the x-axis. Move this point over. 1, 2, 3. Stretch vertically by a factor of 2, so times 2 would take it up there. So there's that transformation of just the first 2. Oh, I like doing it this way because then I can process the information a little more slowly. I guess if I was a student, I'd also be comforted by the fact that at this point I've earned some partial credit. Now I'm gonna do these next two together. I'm supposed to reflect everything over the x-axis, which would just give me this downward facing V, and then move everything up 2. So the reflection doesn't do anything to this point on the axis, so it would just move up to 1, 2. This point would reflect down here and then go up 2. This point reflects to here and then up 2. And there's my nice, happy final answer. All right, well, those are the example problems for this week, spread out over 4 videos instead of 1 or 3, but there they all are. If you have questions, please let me know. Bye-bye.